Okay, then the last ones, 5 through 8, all using our graphing calculator and then analyzing them, okay? So let's go through and graph these out. So let me switch over my camera real quick. Now we've done that, whoops, that's not my camera. So we've done -4 before. That's nothing new. You should already have an idea what that looks like. It's going to be a horizontal line. That's a constant function. So let's go ahead and put that on our paper. Oops, again, that's not what you want. All right. So it was a constant function. We had something like this. And it is passing the vertical line test. The domain goes from left to right. Focusing on the x's. It's using from everything from -infinity to +infinity. Now, the range on this one is a little bit different because it's exactly at 4. So we're going to say just y equals -4 because it's not going anything past 4. It's not going anything below 4. It's exactly at y equals -4. That's a new one we've seen. A little bit of a trick one, but it's not meant to be. This is a linear function. This is a linear graph. It is constant throughout. It does not, go back. This is the one graph that does have a vertical axis symmetry. And you could draw that vertical axis symmetry wherever you would want. Because this line continues left and right, there's a vertical axis symmetry. Because it continues to the left and continues to the right, it would fold onto one another. So this one actually has a vertical axis symmetry. It has an infinite amount of vertical axis symmetry. It's because you got horizontal with a perpendicular with a vertical line. That's always going to be true. So here, 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 these are all vertical axis of symmetry. We're going to say no. And if possible, identify the x and y intercepts. We've talked about that a couple times, and we're trying to jog your memories on what an x and y intercept is. The x-intercept is where it crosses the x-axis. Is it ever crossing the x-axis? The answer is no. Is it crossing the y-axis? The answer is yes. So we have a y-intercept at 0, -4, but we have no x-intercept, okay? We'll keep talking about that. Let's go graph number 6. -x² + 4. Okay, because it's x², I should expect a U-shaped graph. This is quadratic. Because there's a negative out front, I should be expecting it open down to create a maximum. U-shaped with a maximum. Boom, there we go. Get to know the structure of the function. That's going to tell you what to expect. So -x² + 4. Make a nice sketch of it. Doesn't have to be too fancy. Okay. I am going to make it a little bit fancier though. Okay, it is a function. The domain, because this arrows tell me continue to open out to the left and continue out to open the right, the domain is everything here, from -infinity to +infinity. Another way to say that is all real numbers. The range, though, is everything below that ceiling. My ceiling is up there at 4, so I want everything below 4. So I say y is less than or equal to 4. It is a quadratic, we said, because of the x². It is increasing, it is decreasing. It does always have a vertical axis symmetry right here. It does have a maximum, we said. And if possible, identify y and x-intercept. It has a y-intercept on the y-axis at 0, 4. Y-intercept is where it's touching the y-axis at. It's touching up here at 0, 4. And it has an x-intercept at 2 locations, -2, 0, and 2, 0. We will continue to talk about that throughout the year, but an x-intercept is just where it crosses the x-axis at, and it happens to intersect the x-axis at these 2 locations, okay? All right. Number 7, it's an absolute value function, so I should expect a V-shaped graph. Now, because it's a positive in front of the absolute value, I should expect it to be opening up to create a minimum. So, absolute value. Come on. I had of x plus 3 minus 4. V-shaped with a minimum. There we go. So go ahead and graph that. So I started right down there, and I'm gonna go ahead and make a sketch of things. It is a function because it's opening to the left and to right. The domain is everything. The range, though, is everything above -4, including -4. So that's why I said above is greater than or equal to. It is, again, an absolute value, and I should get into, as it's saying, a linear absolute value, because this is made up of 2 lines, and we'll talk about other ones down the road. It is decreasing, it is increasing. We have a vertical axis of symmetry right here. It does have a minimum. So the minimum's down there. And then after that, it is crossing the X and Y axis. So we have y-intercepts. It's crossing the y-axis. Look back at your calculator. It's down there at 0, -1. And it is also crossing your x-axis at 2 locations. It's crossing one over there on the right at 1, 0. And it's crossing the other one at, let me see, count mine, 1, 2, 3, 4, 5, 6. Looks like at -7, 0. So when I sketch mine out, it's not stellar, but that's where the 2 x-intercepts are located that I was talking to you about. And then for the last one, 1/3 to the x. As soon as I see to the x power, I know that's going to be exponential, and I know it's going to be some type of curve, and exponentials are functions. So let's go punch it in. Okay, what I'm about to punch in is parentheses for a fraction. And then I close those parentheses. We've done that before. That is nothing new. Exponent to the x power, and let's see what type of curve that we get. Okay, this is our exponential graph. It is decreasing like that. So we want to sketch that onto our paper, okay? Doesn't have to be fancy. Okay, so on that, the domain is everything. It is technically continuing out to the left and to the right, just very slowly to the left, but very quickly to the right. So the domain is everything. All real numbers is another way to phrase that. And for the range, we want the range to be everything greater than 0. Okay, here's my floor right there. And it's not going to include 0. We'll talk more about that later, but we've seen that now a few times that the range is everything above 0. We said it is decreasing all throughout. It does not have a vertical axis symmetry. It does not have an absolute max or min, and it does have a y-intercept. Okay, the y-intercept, it's right around, if you look at your calculator, up there at 0, 1. It will not have an x-intercept. It looks like it's crossing the x-axis, but it's not. Again, something we will talk about throughout the year in that regards. And I think that does it. So all these are the types of questions we've been looking at that are going to be on your test then for Tuesday.